section 11.2 gas pressure. Go and do video problem 57, which is just pressure conversions after this. Right? So pressure occurs because the molecules are exerting a force over a certain area. And so there's the actual, if you want to calculate, be able to calculate pressure. What a barometer does, a barometer measures that. So here's a barometer. Okay, and what it is, there is a tube of mercury. So here's the tube of mercury, and then here's a pool of mercury. And if you go and look up videos of barometers, you'll see how they work and all that. We don't have to use mercury. The reason why we use mercury is because it's really dense, and so a small amount of mercury will equal atmospheric pressure. So a column of mercury that is 760 millimeters tall will usually equal atmospheric pressure, right around sea level, which is right about 1 atmosphere. Now, if I'm going to use water instead, that column of water would need to be 32 feet tall. Okay, about 10 meters tall, and 32 feet of water is going to exert 1 atmosphere of pressure. So the way that it works is this inverted tube, the mercury won't drop down. The reason why it won't drop down is because we are exerting force on this pool right here. So the atmosphere is actually exerting force on that pool, and then that force is distributed equally, and that's Pascal's principle. Exert a force on a fluid, it will be distributed evenly throughout the fluid, even throughout that tube, because that tube is open to the pool. And so that force keeps the pool of mercury at a certain height. If we have less, if the atmosphere drops, the barometer drops. If the atmospheric pressure increases, the barometer increases. Okay? Now there are different units for pressure. There's atmosphere, which is what we typically use. 1 atmosphere is equal to a column of mercury that is 760 millimeters tall. We can also use torr, which is just sort of like a celebrity unit. It's named after Evangelista Torricelli, who did a lot of work with barometers. And then there's the kilopascal. Okay, and these are also your conversions, and so when you go look at that video problem, you'll see those conversions. So we said we looked at a barometer, and if you ever watch the news, it'll tell you whether the barometer is rising or dropping. And on the news, they're looking at least in America, they're looking at inches of mercury instead of millimeters mercury. Okay, but basically a nice hot sunny day, we're going to see an increase in the barometric pressure. And a rainy day, we're going to see a decrease in the barometric pressure. Okay. So there's a little bit about pressure. We know that pressure changes with altitude. So the higher up in a mountain you go, so let's look at this. Here's some dude standing right there. Okay. Here's a mountain, and here's some dude standing up on the mountain. Right. So we said that it changes with altitude. Let's see. So this, we're going to call this the upper stratosphere. So this, that represents the number of molecules that are on top of that guy's head that are pushing down, exerting force. Now this guy has fewer molecules. So since he has fewer molecules, there is less pressure. So it's a lower atmospheric pressure. When you go up in the mountains. Higher atmospheric pressure when you're not up in the mountains. And then let's say that's at sea level. If we go below sea level, we have even greater atmospheric pressure. Okay? So here you can see how altitude affects atmospheric pressure. So it changes while diving as well. So here's the ocean. Now there's already 1 atmosphere of pressure. So here's somebody diving. Now this person has all sorts of molecules on them. Let's say they go 10 meters deep. That's another atmosphere. So that diver is experiencing 2 atmospheres of pressure. 1 atmosphere from the gas and 1 atmosphere from the water.